Good evening, students. I'll start with the class. In the previous class, we were doing rounding off. So we had seen an example, like suppose if we have, and we want to round off to two significant digits. Okay. So right now these are three significant. Any non-zero number, irrespective of the decimal point, I told you, is a significant digit. And any zero between any two non-zero also is significant. And if there's a zero here, and after the decimal point, it becomes significant. But if there is any zero in front of the decimal point, then it is not significant. So two decimal means we have to always check the third. So we have to round off to 2. So this fellow has to be thrown out. If this number is greater than 5, you have to always add 1 to this. If this number, so now this 8 is more than 5, we have to add plus. So it will become 5.3 after rounding off. So if this is 1, okay, this is less than 5. It's like adding 0 to it, so it will remain 5.21. So this is what we had seen. Now suppose if there are more digits and there's a 5 and all. We have seen less than 5, more than 5. Now what happens if there's exactly 5? Again, same thing, round off to two significant digits. First example. Now this is not like the like how you know, just look at this one, then see it like this on order. It's slightly different. Now, we'll name the number the digits. This is first digit, this is second digit, third digit, and this is fourth digit. So that when I write and give you the rules, you understand what exactly it means. Now, I want it up to two significant digits. So 2 is the next to be cut off, to be thrown out. The third digit is to be thrown out. The next fellow after the significant digit, this part is like unwanted. Okay, so what we have to do is the first step. Take the third digit and compare it with 5. Now compare it with 5. Now what is happening? It is becoming equal to 5, neither less than nor greater than. So what you have to do is, so if third digit is equal to 5, now what is happening? It is equal to 5. If it is equal to 5, check the fourth digit. So which is the fourth digit? It is 1. Okay. Now you just have to check the fourth digit, whether it is 0 or not 0. Okay. If the fourth digit, I'll explain again. Just writing the rules so that you copy and then again I'll explain. If the fourth digit is non-zero. Non-zero means as long as this fellow is not equal to 0. Then add +1 to the second. So these are the rules. If it is 0, then what to do? That will be the next. That also I will teach. Now what we are doing is, as long as this fourth digit is not 0, you just have to add +1. Why? Because the fourth digit is non-zero. If the third digit is 5 now, then we have to move on to the fourth digit. So the answer will be 2.3. One example I'll give you. The rules will remain the same, okay? So that I'm not going to repeat again. So what basically I did is round it off to 2 significant digits. So I wanted only this much. So the next, which I don't want, is the third digit. So I have to take the third digit and compare it with 5. So if the third digit is equal to 5, I cannot decide whether it is greater than or less than. So I have to move on to the fourth digit. Now if this fourth digit is non-zero, just directly add +1 to this. And then the answer will be this. So finally you should have only 2 digits because just want 2 significant digits. Not 2 decimal digits. Huh? Students get confused. Significant means even including the decimal point. What they think 2 significant means up till here. 2 digits they write after the decimal point, not that. This. Second one. So same thing over here also. Round off to 2 significant digits. So just look at the third one. Third one is 5. So directly go to the fourth one. So fourth one is non-zero. Happen plus. The answer would be 8.5. Anybody who has not understood this? You want to tell me the answer of this? Third one, what would be the answer? 6.4. Yes, 6.4. Because it's very simple. Look at this 5. So 5 means directly here. This is not 0 means straight away add +1. 6.4 will be done. So this is to be done when this fellow is 5 and this is a non-zero. Now we'll check what happens if there's a 0. Hope you all have written the rules. When you are left, then just tell me. I've given in simple words because on the textbook and all you'll see like drop off the third term, drop off the uncertain term and all. That becomes difficult. And remember, no one will ask you to write the rules in the exam as long as you have understood to round off, good enough. Next is when there is zero term or no term. No term means it will be equivalent to there is zero there. The first factor. Again, we'll take it round off to two decimal, two significant. Now suppose I want to count, but definitely this much. The same thing. This rule will remain the same. Take the third digit and compare with 5. Second thing, if third digit is equal to 5, check the fourth digit. Now see, now the rule will change. Now what to do? If this is 0. Now this is 0 means don't add 0 here, simply and keep. If fourth digit is 0 or fourth, suppose it means the same as like this. Okay, if the problem was given like this or given like this, it means the same. If the fourth digit is 0 or fourth term is missing, not there only. It's like equivalent of having 0 there, even if it is not there. So what we have to do is, there is no number here. Okay, so this is the rule. Check the second digit. This is an important rule. If this is 0 means you have to come back to the second digit. Normally, finally, we have to convert this. Now, either we have to keep the same or we have to add 1 to it. So what we have to do, we just have to come back to the second digit. Come back to the second digit. Now, if the second digit is odd or even, okay, what you have to check. If second digit is even, keep it same. Keep the digit same or like equivalent, add 0 to it. This is even. So it's like 2 plus 0, it will be equals to 2. So 2 will remain as 2 only. The answer will be 2.2. Because this is even, you have to keep the number same. Keep the digit as it is, means like adding 0 to it. Again, I'm repeating. This was the number given. We have to cut off till these 2 points. So we saw this is 5. So we cannot decide whether it is more than or less than. We have to go to the fourth. Now the fourth fellow is 0. If it is non-zero, directly can add 1 as per the previous rule. Now if it's 0, then come back to the second digit only. Now check whether it is odd or even. So if it is even, you add 0. And if second digit is odd, this digit is odd, right? Plus, as of now it is not odd, so we will not show you, okay, how it works. The next example is, if second is odd number, then add +1 to it. So if this was 3, no, if it was 3 given to me, odd number, then it would become 4 because after adding 1. But this is even number, that's why it remains same. Only if it's odd, you have to add 1. Set the rules. One more example, I'll be 4.65. Again, under rounding of 2 digits only we are doing. So this is equal to 5. So I have to check fourth digit, not there. So that means not there means equivalent to 0. So come back to second digit. Second digit is even. So it will be +0 because it's a even number. So your answer will be 4.6. So whether it is 0 here or not there, you have to come back to the second one. Can anyone tell me the answer?
8.4.
How much?
8.4.
Yes, 8.4. Because this is equal to 5. So we have to check the fourth digit. Fourth digit is 0. So we have to check the second digit. Second digit is odd. That's why plus, so this is odd. +1 is 8.4. So quickly I'll try the answers for this. Okay. Then convert, round off to two significant digits and keep, then we can check whether it's correct or not. As per whatever you have understood, try to find the answer. These are not only under odd and even, including all the rules, okay, we have done before. Here, what is the answer? First one. First, what is the answer?
3.2.
Yes, 3.2. Because this is even. That's why plus 0. Second one,
2.8.
yes, 2.8. Because this is odd, so plus, because this number is missing. Now here, this anyone can tell? Just in case.
2.4.
Yes, yes. Because this is understood the logic. When we have to go to the fourth digit, only when it is exactly equal to 5. But now I want only this much. So this fellow, I don't have to go to fourth digit, because this I know is greater than 5. I told you, any number which is greater than 5, don't have to think, directly add plus. When we have to go to the fourth digit, only if this is exactly 5. But now this is more than 5. So straight away, any number more than 5, you can add plus 1. Yeah, what is the answer?
4.1.
Yes, 4.1. Because as per the rule, whenever it is, wait, 4.1, just tell me again.
4.2.
4.2 it will become. See, don't look at this odd and okay, even though it is odd, see, what is the logic? This is 5. Now we have to go to the fourth digit. So fourth digit is non-zero. So whenever it is non-zero, I told you straight away plus. If the fourth digit is non-zero, will be always plus 1. Answer will be 4 point. The last one,
2.8.
2.8 because it's the even number. So this is how it works, the rules. Now, suppose we have to convert into 3 significant. And anyone just like randomly tell me what will be the answer? Just a guesswork. Okay, first tell me which are the significant figures here. How many significant figures in this?
4.
4 significant figures. So first, you have to remove out the 4 significant figures, because this has no meaning, I told you. Any zeros which are before the decimal point, only towards the end, zeros are to be considered. So this has no meaning. Actually, of course, the significant numbers are, I want to convert it up to 3. So now look over here, the to be dropped off. So this fellow is less than 5 means you have to add 0 to the previous one. Your answer will be Then from there on, like the rules remain the same. Then if there is 5, then you have to check the next digit. If there's no number, then check whether this digit is odd or even. That way it works. The same thing as previous. Up to 3 significant digits. Anyone tell me what will be the answer? So the rule was we were checking with the second and all. No, now it will be just shifted by 1 digit. We want 3 significant figures. What will be the answer?
2.34.
Yes, it will remain 2.34. Why? Because now till here I want. So which I is to be dropped off this one. So I have to check whether this is equals to less than 5 or this. So now this is equal to 5. So I have to move on to the next digit. So this fellow is missing. So it's equivalent to having 0. So 0 means always the last digit, whatever of the significant, check. So this is even number. Even means it will remain same. Hmm? Any doubts? If you don't understand, please interrupt and you can ask. Explain. If you don't understand how you got this answer now, it will be the answer for this. So whatever we are doing is for 3 significant figures. What will be the answer?
7.1.
Yes, directly 7.12, because up till here we want this is less than 5. So you just have to add 0 to it. If this was more than 5, you have to add plus 1 to it. What will be the answer?
3.14.
Yes, 3.14. Because this fellow is equals to 5. So we have to check its fifth digit. Next digit. So this will be non-zero. The next number which is after non-zero is after the 5 is non-zero. We have to add plus 1. 3.1. This one. Yes. Again 3.13. Because again this value is non-zero. So whether you don't even have to check whether it is even or odd. As long as this is non-zero, straight away without looking at this, when you have to come back to check whether this is odd or even, if there is 0 here or no number. Otherwise, if there's a number after 5, straight away it is plus 1. What will be this? Answer for the sixth one.
3.12.
Yes, 3.12. Because this is 0. So we have to come back here. This is even. Given is plus 0. This is how it works. And the last one. So first of all, you have to write out how many significant numbers are there. This fellow will directly go. Because last, if there's no decimal point, this has no significance. So your significant values are this. If I want to here, and this number is less than 5. So when you add, it will be straight away 2, 3, 5. So it's like adding 0. Any doubts in this? You can ask me. Now, the last part of this error, what is the significant rounding off? This is what happens when you multiply or divide any number. So I'll directly explain with the help of example. You are asked to find 6.4 into 0.2. And now you have to understand up till how many answers this you have to write. So the rule is always, if two numbers you have to multiply now, your step number 1 is check significant number or significant figures in each term. Now 2 terms have been multiplied. This is one term. Check the least significant. Least significant means lowest. Round off the answer. Lowest or least significant number. These are the rules. Then I'll explain with the example. Any terms you are multiplying. Suppose if 3 terms also you are multiplying, okay, or 4 terms, doesn't matter. Every single term first you check in every term how many significant numbers are there. Then you check which term has the lowest one, lowest significant number. And that much numbers you'll have to round off the answer. So if 3 is the least significant number of any of the terms, then the answer should have only 3 significant numbers. Now we'll see with respect to this example. How many significant numbers in this?
2,
In this one?
1.
1. Because any 0 before the decimal has no meaning. So there are 2 significant numbers here and just 1 significant number. Which is the least? The least for the low. So my answer should also have just, you have to round off to, round off the number to 1 significant. Why? Because among these two, 1 is the smallest. So multiply the numbers and you'll get some answer. So 6.4 into 0.2 will give you 1.28. But I don't have to write this. You have to round off to how much? Now they will not tell you. Then You have to know looking at this. The lowest is 1. 1. I want only this one. I want up till here. To check the next number, I don't have to bother about this. 2. So 2 is less than 5. If this is 5, then I have to go back to check to this fellow. Okay, to the next digit. If this fellow is 5, then I have to check. Otherwise, just directly 2 is less than 5, so to state 0. The answer will be 1. Here, 2 is less than 5. So just have to add plus 0. Means it will remain same. If this was more than 5, then I add plus 1. Then answer would become 2. Now I want to divide this number. So here automatically you know that this has 4 significant numbers and this has 2 significant numbers. So least is what? 2. So answer I have to round off to 2 significant numbers. Answer if you calculate you will get it as 3.04. Because of this round off to 2. So this is the least among the round off to means I have to 4 is less than 5. Then nothing will happen. 0 will be my answer. This is how you have to work the rules. Okay. Now rounding anyways, you know, I've already taught up till 2, till 3 also. Even for 4 also, it will apply the same logic. Then you have to check with the 5th digit, the next number which is to be dropped off. So this is when you have to multiply and divide. Now suppose if you are adding, the rule is in addition of subtraction, the final result, final answer you can say, should have as many decimal places now, not the significant figures, as are there in the number with least decimal place. Here you have to check for the least decimal places, not significant numbers. Please underline and keep. Now consider I'm adding How many decimal places are there? 2. Yeah, I'm checking decimal places, not the figures. Significant figures would be 3, but that we have to check when you're multiplying or dividing. In addition, just this. Here also there are 2 decimal. Here there is only 1 decimal. Means how many numbers are there after the decimal point? Which is the least? So your answer should be having only 1 decimal, meaning 1 decimal number after the decimal point. This is how much? 3.94. While rounding off, that logic will be the same, whatever you were round. How much it should have? 1 decimal. Should be here. Now check. 4 is less than 5. We have add 0. If this was more than 4, no, then it would be 1. And then answer would be plus 1 means 10. 10 would become your carryover. So 4.0 would have been your answer. In case if this number was like this, then you have to add plus, because this number would be greater than 5. Then answer would become 4. Okay. 1.1 plus 7. Just add this and see. $21. Okay. Now, how many decimals? This is here. 3 here. 2 here. 3. I want up till minimum 5. So plus 5. This is how it works. Okay, even for subtraction, it will remain the same. First subtract and then see how many. If there was minus, also same logic. The least decimal places you have to pick in the answer. So these are the rules about significant figures and rounding off. Then the last part, some convergence. Certain colleges, they don't do this. If it's not done in your college, you can just ignore it. This is based on the dimensional analysis part. I have not done that because only 1 or 2 colleges do that. This to do that. Very easy it is. Convergence. Using dimensional analysis. Okay, before the starting of the class, we had seen there are two types of this, or three types you can say: CGS, FPS, and MKS systems, which we had seen in standard international system, SI system. One was CGS, or even you can say MKS, and one was CGS. In MKS, what it is always M means meter, K means kilo, and this means second. In CGS, this means centimeter, this means gram, and this means. Okay, now also sometimes this is usually whenever there is SI unit, now you have to mostly follow this MKS system. Now this unit, there's force which we had studied. Okay, physical quantity force. In SI system, we had seen that unit of force was Newton. Okay, but the same thing under CGS system, it is also called as dyne. The same force as units can be named in two different ways. If you are measuring it in terms of meters, kgs, and second, then it is called as Newton. And if you are measuring that force in terms of centimeter, gram, and second, then it is called as one dyne. And this is called as 1 Newton. If you are measuring in kilos and meters. If you are measuring in terms of centimeter, it is called dyne. Same way, even work, only these two things will be different. In SI system, it is called as joules. Here it is called as erg. It's the same force, but it depends on how you measure it. In terms of meters you are measuring, and it is called as joule. And in terms of centimeters, if you are measuring anything, how much work and all is being done, and it is called as erg. The dimensions will always remain the same. Force and work and both the same. That MLT, that will remain same. So now we convert. The question it can come as convert 1 Newton, or they may not specify, just say Newton into time. So if they have not mentioned anything, it means convert 1 Newton, after assume it as 1 Newton into, don't know how many times it will give it. So Newton and dyne, just now I told you, they are units of force. This is what SI system for the MPS, and this is the CGS. This you have to know that Newton means it is the MKS system, meter, kilogram, and second system, and dyne means centimeter, grams, and second. What is the dimensional formula for this force? M LP, this is 1, 1 and minus 2. This is fixed in the table which you have already done. That will not change. Whether you write for Newton or whether you write for dyne, this powers will never change. We'll take two different letters so that we don't get mixed up with both. We'll use N1 for Newton and N2 for dyne. Now N1 means number of newtons. This is already assumed. It is 1. This we don't know. We have to find out how many dynes we will get. Now we know that N1 Newton will be N number of Newton will be equal to this many dynes. Okay, no matter what is the conversion, always take like this. N1 times whatever we have is given will come here and conversion will come here. Okay, this side will be N1, this side will be N2. Now this is no, you know that it is 1 because this is fixed. I told you nothing is mentioned, it is 1. If they give you convert 2 newtons into dynes, this will become 2. Now just put it as MLT 1, 1, 2. Same the other side also same it has. M because force will always remain same for both the formula. But now just to differentiate, this is N1 and N2. Here this side will put 1 over here. And this side will mention it as, because powers will definitely remain same. They will not change on both the sides. Only one we have to differentiate just to so that we don't get mixed up. Whose is what? N1 means, so we'll use for Newton. And for dynes, we'll use 2. How we use X1 and X2 like that. It is not a power, it is just a name so that we don't get mixed up with both of them. Now what I'll do, I want to find N2 value, how much it comes. This is multiplication, no? So this, if I take on the other side, it will go to the division part because there's multiply. So this term will go down here. In the next step, what will be N2? N2 you keep there only. This will go. Solving 1 into this is anyways this. If you all are not understanding enough, please ask. No. This will separate them. Common power, both has 1. We'll just put then N we will separate. These are the fixed steps which you have to follow. If not done in a college and the chapter is over, then you can just ignore this part. Then same thing, P1 and P2. Now the power is minus. So basically what I did, I just separated them. M separate, L separate, P separate. The common power I wrote out. This one was for whom? Newton. Newton was for what? MKS system. MKS, no? This was for Newton. And this was for dyne. 2 was for dyne, no? So MKS system means I told you this will be in kgs. And this fellow will be in terms of grams. For length, this is in meters and this is in centimeters. For time, both are in terms of seconds, so that will not change. For CGS also it remains as second and MKS also it remains as second. So write the MKS unit for Newton and the CGS for dyne. Any doubts till here you can ask. Now we'll try to convert it. The bigger ones always we have to convert. Now between grams and kg, obviously kg is big. So we'll write in terms of grams. So you should be knowing and write on the top of the page and give definitely will know. 1 kg is how many grams? That will be 1000 grams. Same way if you want to do ulta or in terms of powers if you want to do. By 3, there are 3 zeros, no? Always it can be 3. Also write in terms of same way ulta if you want 1 gram will be always 10. If smaller quantity you are writing in terms of bigger, it will always be minus. Anyways, now this is what we should be doing. 1 kg. So this is 1 kg means I can write it as 1000 grams. Same way, 1 meter will be equals to 100 centimeters. There's no need to convert, both are in terms of second. Now what will cancel? Gram and gram will cancel. Centimeter, centimeter will cancel. Second, second will cancel. What remains is 1000, 100, nothing. Now we'll just remove out them from the bracket. Write in terms of power. Raised to 1 is 1000 only. This also raised to 1 is 100. 1 raised to any power is 1. So what is the calculate? And 2 is this. So total, how to multiply? Whenever this, don't do like this and then waste time. Directly add the number of zeros straight away. 3 are there, this side 2 are there, total 3 plus 2 will give me 5. This will be answer. In terms of powers, I want to write how many zeros are there? 5. So 10 raised to 5. 10 2 is 10 raised to 5. So 1 Newton is equals to N2 value is 10 raised to 5. So this is answer. Any doubts in this? You can ask. Same way, we'll convert dyne into Newton. So what you have to basically assume, nothing means 1 dyne into Newton. How many newtons? So number means you have to assume first one is 1. So this side will give N1 dyne. I'm not writing that same data again because we know that same thing it is. Dyne and newtons are both units of force. This is in CGS and this is in MPS. And this formula also MLT, that also will remain same. I write the same as the previous one. Directly I start the formula. 1 dyne is equal to 10 to newtons. We don't know this one. This you know there's 1. Dyne, same thing. MLT into this. ML. This will never change. So both force only. Just use the letter 1 this side because I'm using 1. 2 and because I'm using 2. Now keep N2 there only. And take this whole thing down. Now you have to be careful. This is dyne. And this is was for Newton. And 2 means for Newton. So dyne will be in terms of CGS. So this is the CGS system. And this is MPS. Newton is bigger one. So put the CGS here. CGS means this will be centimeter. First, before that, we'll separate it. The top one is CGS. This will be in terms of centimeter. This will be in, sorry, mass, no? This will be in terms of kg, gram, and this one will be kg. And length in centimeter. This one will be meter. This one will be second. Now the top one is less because the dyne is the smaller fellow. Gram, centimeter, second. Here Newton is the. Anyways, while converting, you have to convert the bigger one only. What you do? Kg will be 1 kg is nothing but same thing. 1000 grams. Centimeter. 1 meter will be 100. So what is going to remain? 1 upon 1000. 1 upon 100. 1 meter. And then this all will be 1. So total here 5 zeros. can always keep this on. You can directly write the answer by calculating. Now, if you take this on top, there is no 10 raised to minus. So your answer is 1/9. So this is the conversion. This is how it works. Any doubts in this? You can ask. In this, convert. I told you should know that Joule and Earth are nothing but the units of work. Joule is the CGS system, sorry, MKS, or the SI unit, or in nothing but the CGS. And then you have to know the dimensional formula for work. That is 1. This is fixed one, which is already given in the table. Okay. Now start with the calculation. I told you always start whatever N1 joules or joule equals to N2. N1, nothing is given also, it means 1. And joule. Joule means the same thing you have to put both sides. First side the same thing. Just put 1, 1, 1 here for this one. And then both will cancel out each other if you don't put different letters. And then N1 will N2 will get as 1. That will not. Now keep N2 there only, bring the other term this side. Separate out the power. This is 2 here now. Will be 12. Check. Joule is on N1 and 1 in joule. And this one is so this is MPS and this is CPS. This will come in terms of meter. So what is that? Kilograms. Mass. Okay, M for mass. Mass. Length is in terms of meters and T will be in terms of seconds. And then you convert. This will be 1000. Now square means these zeros will double. This is square. Total 1, 3, 4, 5, 6, 7. Right then 1, 2, 10 raised to 7. In the same logic, you have to apply ulta. So you will get 1 minus value. Same how we had done, no? In this Newtons and time. This side erg will come up, joules will come down. So this will be gram on top, pages. Same way, if suppose like this has been given, convert 2 dyne, 2 Newton, whichever. What you have to take is just this. Anyways, we will take N1 newtons is equal to N2 dyne. So, newtons is equal to N2. Then to perform it and calculate. So final answer, if you calculate, you will get basically 2 times 10 raised to 5. This one, that's the only difference. So if they give you 3 newtons into dyne, say it will be 3. But other remaining, everything will remain same, the calculation. Any doubts in this conversions? No. Same applies for this also, joules. So whichever amount they take, give, put it fine now. Next up, without using dimensional analysis, suppose it's a direct conversions. For direct conversions, basically you have to remember this. I told you 1 kg is 1 kilogram means always 1000 gram. It is same as 10 raised to 3 gram. One gram is ulta. If you know this, no, this is very simple to find. Keep gram here only, and this fellow goes down there. So if you are taking the whole number down, 1 remains. So 1 gram is nothing but 1 upon 1000. Bringing in this side. And when you take 1 top, it becomes mine. Same way, 1 meter is 100 centimeters. So 10 raised to 2 centimeters. Same way, 1 centimeter will be 1 centimeter. If you want to know here, bring this 100 down. 1 upon 100 meters. It is nothing but 10 raised to minus 2. Then, you know that 1 minute 60 seconds. 1 hour is 60 minutes. Want to convert 1 Another 1 minute is 60,000. So looking at that logic, just see here, 1 minute is 60 seconds. So what will be 1 second? If I want 1 here, take the 60 this side. 1 second will be 1 of 60 will go to this. That's how we have to do. Any doubts in this normal conversions of units? So the question is, convert 2 meter per second square into kilometer per minute square. Let us take this 2 minute per second square. Now already I given you the conversions. I want in terms of kilometer. 2 anyways the number there. 1 meter, just ignore this. So like m means meter. So meter into kilometers conversion is always told me how much value 10 raised to minus 3. 1 meter is nothing but 10 raised to minus 3 kilometer. If kilometer was here and meters were this side, it would be plus. Now second I want to convert into minute. So second into minute is 1 by 60. There's a square. Second square means 1 by 60 minutes square. Anyone who has not understood the substitution, you can ask. Why am I doing this? I want to convert it. They have told to convert. So meter into kilometer conversion I've already given, that is fixed. Whether you want to buy hard, whether you already know, that's fine. So wherever there is second, you want to convert in minutes, this is fixed, 1 by 60 minutes. So this square means it will apply to all the terms. So 1 square will be anyways 1. 60 square is 60 into 60. 1,100. And minute, minute square. Now it's like A, nothing is there, it's upon 1. So this will become A upon B, C upon D. This fellow will reverse, will go up. Like this I told you. Not, nothing is there, it's like A upon 1 and 1 upon. So who will go reverse? Step. Numbers will always get modified to number. So 7,200. So at the end, kilometer is on top. Already got kilometer per minute. 10 raised to minus 3 means you can shift 3 decimal points this side. You have to make the value small. Minusing means whenever you're multiplying by minus value, it means you're reducing the value. You cannot add zeros. Plus means you have to add zeros. Minus means you have to reduce the zeros. You can shift this by 3 decimal points. So you are here. 1, 2, we will get it as 7.2. That is the answer. The last one. This per hour. This slash means upon hour. Simple. 72 kilometers per hour. Kilometers, I want in terms of meters. 72 anyways will remain at the side. Kilometers, okay, and 1 kilometer is 1000. If you want, you can write and keep. If I'm not given. Understood. Basic from 10th standard also you should be knowing. 100 meters, 1000 meters will give you 1 kilometer. 1 hour into seconds, 3600. Zeros, zeros will cancel. 36 plus 72 into 10, 20 meters per second is that. So any units, if you know what is the conversion, means how much kilometer will give you meters and meters give you kilometers. Same way, see, 1 kilometer is 10 raised to 3, which is same as 1000 meters, and 1 meter will be ulta. Stop here. With this, I finish with the chapter. There is one topic which is something called as parallax method, like this, to measure. In case if it is done in your college, then only you let me know. It's a small 5-minute topic. Then only I do, because normally colleges they don't do it. Now, it's covered in your college, and if you have not understood it, you can tell me. I can explain while revising the chapter or anytime. With this, I'll finish. Next class, I'll start with a new chapter.